Uh, that was the first lecture, and we discussed some concepts about number system. Let's take a quick recap that in this topic, number system, what things we studied, and then after we shall take exercise questions, NCERT exercise questions in this video lecture. In the last video session, we discussed what are naturals, the basic numbers, natural, whole, integers, isn't rationals, irrationals, and finally real numbers. Right? We saw the definition of mainly rational numbers. That what are rational numbers? Rationals are those which can be written in P upon Q form. The numbers which can be written in P upon Q is in fraction form, where P and Q are what? P and Q are integers, and Q is a non-zero integer. Then such numbers are called as rational numbers. We saw one property of rational numbers, and that is very helpful in determining whether any number is rational or not. And what are those properties? That rational numbers means the number which can be written in the form of fraction P upon Q may have either terminating decimal expansion or recurring decimal expansion. Right? Terminating decimal expansion like 1 upon 2 has 0.5, or recurring decimal expansion like 1 upon 3 has 0.333, etc. Right? Often we show it by 0.3 bar also. So this is about rational numbers. Then we discussed some more points, that how to show these rational numbers on number line, how to show irrational numbers. Then the other point was irrational numbers. The numbers which are not rational but real are known as irrational numbers, and various examples of irrational numbers you can write by writing the numbers which are not following these two properties. Right? For example, this is a rational number, irrational number. Right? Because dot 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 is there. It doesn't have a terminating decimal expansion, and moreover there is no fixed number which is getting repeated, isn't? The pattern is changing. So the number is irrational. So like this we can write various irrational numbers on the and if we can show them on the number line also. One more example is there, that roots of primes like root 2, root 3, isn't? Root 5, root 6. These all are roots. 6 is not prime, but root 6 is irrational. So like this, various other, in fact, infinite also uncountably many infinite numbers are there which are irrational. Right? One more theorem we have seen on the last turn, that whenever we see number line and we take any two rational number, for example 0 and 1, there will exist infinitely many irrationals between them, and if we take any two irrationals, infinitely many rational numbers will exist in between them. And if we take these two together, rationals and irrationals together, right? So what does it form? This makes the whole real number set. So real number means it can be either rational numbers or it can be irrational numbers. So like this we discussed some points yesterday. Let us take now some exercise questions. These are NCERT exercise questions of 1.3. Some questions let us discuss. The first question says, write the following decimal in decimal form and say what kind of decimal expansion each has. just a revision of the previous work. It is 36 upon 100, right? Let's write them together and then after we'll discuss. And some more are there. So if this easily can be converted in decimal form, right? We have to tell that which kind of decimal expansion it is. So this is terminated, so this is terminating decimal expansion. This you have to go for a proper division. You have to put a decimal, 10, right? It doesn't go 0, 11 nines 99, and again 1, right? Again 0, right? It doesn't go, then again 0, and 11 nines are 99, and again 1, right? So this number 1 upon 11 in decimal form, and it will, because remainder has become same, isn't it? So it will keep on repeating itself. 09, 09, 09, etc. Right? This can be written in the manner 09 bar also, right? So which decimal expansion it is? Recurring decimal expansion, isn't it? This number also can be expressed in this manner, and you can give a division of 1 divided by 8, and this will become 1, 8 ones 20, 8 twos are 16, 40, 8 fives are 40, and this has become 4.125 and nothing more, right? Has been terminated. So this is a terminating decimal expansion, isn't it? Then next is 3 upon 13. This also you can give a full division. 13 can be used as divisor, and you can divide 3 by 13, and if you do it 0 point, you have to use decimal. No, 2 times only it will go. And this will be 4, isn't it? Then 40, 13 threes are 39, 1. Furthermore division, sevens are 91, 9, 10, 90, Six, 13, 6, 78, and it will be 12, isn't it? Then 1 0, then 13 sevens are 117, isn't it? And 3 again. And as it has become 3, the question was 3 upon 13. Then again you have to divide 3. The remainder has become same as the original one. Here also it was 3 only, right? So again it will start 2, 3, 0, 7, 6, 7. And this will repeat itself, right? So this is the way you can go for division, and after that the only notable point is here that as and when the remainder becomes same, at any place whatever the remainder was there, and here if you get the same remainder, again the same process will start, and the digits that are appearing after decimal will start repeating themselves. So this is the way how recurring decimal expansion can be written. और जो terminating वाला है उसमें कोई समस्या ही नहीं है. Question 2 also is based on similar pattern. Let us see. They are saying that there is a number 1 upon 7 and whose decimal expansion, if you find, it comes 0.142857, isn't it? Repeating itself. How many digits are there? 6 such digits. They are asking, can you predict what should be the decimal expansion of 2 upon 7 and 3 upon 7 and etc. etc. Let us think. If you divide 2 by 7, without going for proper division, just one digit I am trying to divide, you will use decimal, 20 will come and it will go 2 times. 7 2s are 14, isn't it? And then 6 will remain and 60, and if you apply the division, it will be 7 8s are 56, isn't it? So if you see the pattern, 2 8, the same thing will come. It will start from here, but it will start from 2 8, and after that same types of remainders will come and the same kind of division will go, right? But after 4 again 2 will come, right? Same thing, same digits will start repeating it themselves. Then you can use a bar over them, right? Now you can see the pattern that when it was 1 upon 7, it was this. When it is 2 upon 7, it will go, first digit will be 2. Just one time you have to go give a division, it will go, first digit will be 2. Right. Similarly, if 3 upon 7 is there, right? If you use decimal, it will be, first digit will be 4, isn't it? 4, and then you can use, and again after that 4 will come, and you can use bar over that. Similarly, 5 upon 7 and 4 upon 7 and 6 upon 7, you can write the decimal expansion. This is. तो ये तो थी बात कि डेसिमल एक्सपेंशन हम किस तरह से लिखें और ये डिसाइड करें कि वो टर्मिनेटिंग है या रिकरिंग है. Question number 3, let us have a look. They are asking, now it is quite opposite one of the previous question. They are asking that there is a number 0.6 bar and we have to write in P upon Q form. In fact, 3 such questions are there. Let's write them together and then we shall take them. 4 7 bar. Bar is there only on 7, okay? And the third one is 0.001 bar. Any one we can take. Let us take this one. Let us do second one and then others can be done similarly. So the way is, you should begin with the target is what? We have to write in P upon Q form. We have to write it in P upon Q form. So you begin with let x equal to 0.47 bar. Let me write in expanded manner 0.4777, right? Only one digit is getting repeated. And the rule is that multiply with 10 if only one digit is getting repeated. Multiply with 100 if 2 digits are getting repeated. Multiply with 1000 if 3 digits are getting repeated. So I am going to multiply both sides with 10. And this will become, decimal will shift one place this side, 4.77777, etc. Let me write once again the smaller number. Give a subtraction. This will become 9x, no doubt. And this how much? Isn't it? 4.3. And then x, easily it can be written right. So this is the way how we can write these numbers in fraction form, P upon Q form. Fourth is a nice question, amusing question. They have given you a number. In which form it is? Let x equal to, let us begin and give a name, 0.5. 9, 9, 9 and up to infinity. So it has, it is a rational number. It has which decimal expansion? Recurring decimal expansion it is. Now they are asking first that first you write in P upon Q form. So the same thing, multiply with 10. Both sides, write the smaller number again. Subtract. So x becomes how much? X becomes 1. So that's why they are asking, are you surprised by your answer? With your teacher and classmates discuss why this answer makes a sense. See, when 0.9, if you see the number line, this is 0.1, 0.5, 0.9 and 0.99999 up to infinitely many places. If you take the number, automatically you will reach where? You will reach at 1. So this is correct to say that when we take infinitely many times 9 after the decimal, this is nothing but 1. So this is quite right. Similar, fifth question is also based on the same track. They are asking that 1 upon 17 you write in form of decimal and you check that how many repeating block of digits will appear. So this I am leaving for you. Please, of course it will go long division. So 1 upon 17 will be very lengthy. I think 16 digits should repeat. Sixth question. Look at the several examples of rational numbers in the form P upon Q, where P and Q are integers with no common factor other than 1 and have terminating decimal expansions. Can you guess what property Q must have? They are saying that all those numbers of P upon Q form which have terminating decimal expansion. This is a quite interesting question. So let us see this question. Sixth question. They're saying all those numbers which have terminating decimal expansion, what property Q must satisfy? If I take some example, 1 upon 2, 0.5. Furthermore, change this. 1 upon 3 if I take, right? It will not be a terminating one. 0.333. So this is not the terminating one. 1 upon 4 if you take, 0.25. Isn't? 1 upon 5 if you take, 0.2. 1 upon 6 if you take, it will become how much? 0. Right, like this. Now this is also not terminating decimal expansion. So even 1 upon 7 also if you take, it will also, we have seen in earlier question, it will also not terminate. So if you look at 1 upon 8, 1 upon 9 also, if you see, this one will have terminating, this one will not have terminating. 1 upon 10 will have terminating. So what are the numbers which have terminating decimal expansion? These are the numbers. This also will not have a terminating one. This has, this has, this has. So if you collect them all together and observe among these numbers, then what you can conclude? See, 1 upon 4 also contains 2. 4 means 2 into 2, 2 square. 8 means 2 cube, right? 10 means 2 into 5, right? So I think it is correct to say that any number which is of the form p upon 2 to power something into 5 to power something, say m and n, that will have a terminating decimal expansion. सीधे शब्दों में बोले तो डिनोमिनेटर में सिर्फ 2 या 5 की पावर्स ही आनी चाहिए, या डिनोमिनेटर का जो फैक्टराइजेशन है that should contain only the powers of 2 and powers of 5. If 5 is n can be 0 also, right? 5 may not be there as a factor. That will work. There's a 2, 1 upon 2, 1 upon 4, 1 upon 8. Yeah, 2 may not be there as a factor. जैसे 1 upon 5, है ना? या 1 upon 25. This also will have a terminating decimal expansion. So any number which is of this form, where p is any integer, will have terminating decimal expansion. So this we can keep remember, and we can use it as a theorem also. Let us see question 8. The next one says that write 3 different irrational numbers. Note the point, irrational, between 5 upon 7 and 9 upon 11. So we have to write here 3 irrationals between them. 3 irrational numbers. So I think it's good if we convert them in decimal form. So 5 upon 7, and not full, but some digits. 7 sevens are 49. 1, 10 upon 7 means 7 ones. The 7, something. Right? Some more things will come. Not the 1 is not getting repeated. Some more digits will come. 9 upon 11 means 0.8. Right? 90 upon 11. 11 8s are 88. 2, 20. 11 ones is 11. And some more things will appear. Right? I think this is right. Now, you have to write 3 irrational numbers between them. So, irrational numbers means those numbers which have non-terminating, non-recurring decimal expansion. So, if I write non-terminating and non-recurring decimal expansion, there may be many numbers. Let us see this one. 7 5, suppose I take 7 5 0 1 0 0 1 0 0 0 1 and so on. Right? This is one irrational number because it is not a recurring one. It is not recurring because, and this is not terminating. This is not getting ended, and the numbers which are coming, digits which are appearing, have no fixed number which is being repeated. Right? This is in a pattern, although it has a pattern, but there is no fixed number which is getting repeated. That's why it is irrational. But हमें तो 3 लिखनी है, no problem. Same pattern you can use, any digit you change. 7 6 ले लिया मैंने. There may be innumerable ways actually. Right, many numbers can be written. The next one question in this exercise 1.3 is that classify the following numbers as rationals or irrationals. See, roots of primes are irrationals. Root 23. Some examples are there which we have to determine whether they are rational or irrational. Root 23, root 225, 0.3796 and 7.478478 and etc. And the last one is 1.1010010001 and furthermore zeros etc. Up to infinity. Now we have to, this dot plays an important role. Suppose the number has only these many digits, then it will be rational. But dot is there, it is going up to infinity. Now let us check one by one. This is root of prime, it is irrational. Root 225 is nothing but 15. 15 square is 225. So this is nothing but 15. This is rational. Terminated, rational it is. This is nothing but 7.478 recurring decimal expansion. So this also is rational it is. Isn't? Here it is non-terminating one, and moreover no fixed number or set of numbers, digits which are getting repeated. That's why it is irrational numbers. Right? So these are the questions in the exercise 1.3. Now let us take exercise 1.4, which is also based on showing these rationals on the number line. Let's take it. Of course, those who have watched yesterday's lecture, they must have completed it or must be able to do it. But let's take, for revision's sake, this exercise 1.4. There are two questions. One question is that visualize 3.765 on number line. Okay. Let's draw a number line. 0, 1, 2, 3, 4, 5. And first determine that 3.765, where is the chance that where on the number line it will lie. See, 3.5, it will lie between 3 and 4, right? Here somewhere, this 3.7 nearby. So we have to draw its magnified version. And now I am going to write only 3 and 4. And now divide this space between 3 and 4 in 10 equal places. So 3 should be seen as 3.0. So the next number will be 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and 4.0. 3.765 we have to see, and 3.765 is more than 3.7 and less than 3.8, right? So the chances are that this number will lie in this interval. We have to draw one more line, number line, which is the magnified form of this part of the number line. So I will begin with 3.7, right? 3.7 should be seen as 3.70. So 3.71, 3.72, 3.73, 3.74, 3.75, 3.76, 3.77, 3.78, 3.79, right? And next is 3.8. This is. Now my number is 3.765. So 765 will lie between this and this, right? It will be more than 3.76 and will be less than 3.77. Now let me draw one more. No, you can magnify this, and this will be beginning with 3.76 and the end will be 3.77, right? So 3.76 you should see it as 3.760 and 3.77 you should see it as 3.770. Now in between 60 और 70 के बीच में क्या आएगा? 65 आएगा. So in between will be 3.765, है ना? मुझको 765 शो करना था, मैंने बाकी लिखे नहीं. So just direct in center it will appear. So this is. Now the next question. So this is called as, the method is called as successive magnification. Yeah. Magnifying glass you must have seen. So Successive means one after the other. So magnifying successively one after the other. The next question is visualize 4.26 bar up to 4 decimal places. Now this question leaving for you people. 4.26 bar we have to write, but up to 4 decimal places. This was up to how many decimal places? Up to 3 decimal places. तो 3 डेसिमल प्लेसेस है तो इतना तक गया, 4 है तो एक और स्टेप तक जाएगा, राइट. बट 4 डेसिमल प्लेसेस तक इसका वैल्यू क्या होगा? लेट्स सी. 4 decimal places means you write 2626, that much. So this we have to show on number line. So please try this. I hope you can do it. Students, this was I'm very sure that this was a quite easy work. You might be thinking it was not needed even to discuss because many questions are similar, but for revision sake, if some people also may have doubt, we have discussed it, this exercise, these questions, some more questions of some more twists, variety we will take in next lectures, and in the next video we shall discuss that what are the properties of exponents, what are the properties of surds, how they get multiplied, how we simplify when the denominator also contains some irrational numbers, some radical signs, then how to simplify those numbers, and some more things. Thank you. Keep learning, keep sending your doubts to me. We shall certainly take all those doubts in our next video lecture. Thank you everyone.
एक्सप्रेशन देना पड़ता है सीक्रेट की